Hey everyone, this is Bhargav Sutar, and today we are continuing with the topic discounting. Okay, now in this today's session we will discuss what is a combination and what is a binomial coefficient. Previous session we discussed about what is a permutation and what is a pigeonhole principle. Now first let us understand what is a combination. Now selection of a set of R elements from a set of n distinct elements where order does not count is called a combination. Now permutation, that is an arrangement, and combination, it is a selection, okay, where order does not count. For example, consider a set of letters, this ABC, okay, then this A, B, B, C and AC, they are combinations of the three letters taken two at a time. Okay, so here it is a selection. So if we select this AB or if we select BA, but that does not change the selection, okay, because both the elements are same. But for arrangement, it matters, the order matters. So that means if we arrange AB or if we arrange BA, then they both matters. So here in combination, it is just a selection without considering the order. In same manner, ABC is the only combination of these three letters taken three at a time. Let us discuss theorem. So the number of combinations of n objects taken are at a time. So if we have one formula, in the permutation we had this NPR, and in combination we have this NCR. That is the notation, and this is also, this C stands for combination, and NR. So that is the combination of n objects taken R at a time, or simply this NCR, and its formula is this n minus 1, n minus 2 up to n minus r plus 1 divided by r factorial. Okay, so that means n factorial upon n minus r factorial into r factorial, and this is important, we will use it. Let us discuss examples. So the question is, a committee of 5 people is to be formed from a group of 4 men and 7 women. Okay, so how many possible committees can be formed if at least 3 women are on the committee? Okay, so we have question, we want to create, or we have to form a committee of 5 people, okay, from a group of 4 men and 7 women, and the condition is that there has to be at least 3 women on the committee. Here if at least 3 women are on the committee, so that means we can have a women or that means we can have a committee of women with 3 women, 4 women or 5 women. Okay, so either it can be 3 or 4 or 5. So what we will do now, the first step. Now if 3 women are in the committee, then the number of ways to form a committee are what, or how many numbers are there? See, we want to form a committee of 5 people, okay, and the first part is a committee contains 3 women. So now how many total women are there? We have total 7, and out of 7 we will have to just select 3 women. So that means the 7C3. Okay, so 3 are selected. Now we want to form a committee of 5 people, so that means 2 are remaining, so they are from obviously men. And how many total men are there? There are total 4 men. Okay, so that means 4C2. So 7C3 into 4C2, so that means 210. Okay, so this is the first part. Now if 4 women are in the committee, then the number of ways will be what? Now total 7 women are there, and we have this part 4 women. Okay, so out of 7, the total number of cases are 7C4. Okay, so the total number of ways of selecting 4 women out of 7, so that is 7C4. Now we have the committee of 5 people, okay, and total 4 men are there, so only 1 remaining, so that means into 4C1. Okay, so 4C1, so that means the total number of cases are 140. And last step, if 5 women are in the committee, so if 5 women are in the committee, then now total how many women are there? We have 7 women, and out of 7 we want to form a committee having 5 women, so the total number of cases will be 7C5. Now you can see that here only 7C5 will be there. Why? Because we want to create a committee of how many people? That means 5 people. So we have already selected 5 people, so there is no room for men. Okay, so that means 7C5, so that means 21. Now we will combine all these cases, so hence the total number of ways having at least 3 women will be 210. That means the addition of all these 3 cases, that is 210 plus 140 plus 21, that is 371. Now second question. Now from a deck of 52 cards, a 5 card handle is dealt. Okay, so how many distinct hands can be formed if there are at least 2 queens? So now see, the total number of ways are what? For 5 hand card with no restriction. So it will be, we have obviously we know that there will be 52 cards. Okay, so 52 C5. So the total number of ways will be this 52 C5. Now we have in the question there has to be at least 2 queens. Okay, so we will just do this sum in a different manner than the previous one. Okay, so if no queen is included, then out of remaining 48 non-queen cards, the number of ways will be what? So if no queens are included, that means total how many queens will be there? Total 4 queens will be there. Okay, so we are just subtracting that. So that means 48, 52 minus 4, that means 48, and out of this 48 we will select this 5 cards. So that means 48 C5. Now if only one queen is included, then out of 4 queens we choose one. Okay, and out of remaining 48 we choose this 4 cards. Okay, so what will be the number of cases? That means 4C1 into 48C4, because the queens are total 4 and the remaining cards are 48. So 4C1 and 48C4. So therefore the hand of 5 cards can be formed in how many ways? That means here 52C5 minus 48C5, that means no queen, plus only one queen, that means 48C4 into 4C1 ways. So these many ways will be there. See what we have done here. Here we have found all the total number of cases minus this no queen plus only one queen, because in the question we have at least 2 queens. So we done here in a different manner. That means we can also do this sum as previous. How? See, there are at least 2 queens. So that means 2. So it can be either 2, it can be either 3, or it can be either 4. So just take all these 3 cases. That means queens having 2, 3, and 4, and then add it, or in this manner. That means 52C minus. That means all total cases minus only one and no queen. Okay, so both the answers will be same. Let us discuss binomial coefficients. So the binomial theorem, we know what is a binomial theorem. So the binomial theorem gives the expansion of this a plus b raised to n, where n is a positive integer. Okay, so what is this? So a plus b raised to n, that is equals to nc0 into a raised to n b raised to 0 plus nc1 a raised to n minus 1 b raised to 1 plus nc2 a raised to n minus 2 b square up to ncn a raised to 0 b raised to n. So what is the pattern? This nc0. Okay, now a raised to n, whatever the power, it's this power of a starts from n. So a raised to n, and power of b starts from 0. So b raised to 0 plus here just numbers are increasing. So that means nc1 into a raised to n minus 1. So whatever the power, just the power of a is decreasing. So that means a raised to n minus 1 into b raised to 1, and same manner the power of b is increasing by 1. So b raised to 1 plus nc2, that means increasing, a raised to n minus 2, that means decreasing, and b square, that means increasing. So this will be the binomial expansion. So this coefficients, this nc0, nc1, ncn, they are known as binomial coefficients. And S, why? Because they are present in the expansion, that means the binomial expansion a plus b raised to n using the binomial theorem. So these are the binomial coefficients. Note, this we'll use, okay, so NCR equals to is same as this NC n minus r, and the second result is NCR plus NCR minus 1 equals to n plus 1 CR, where r is in between 1 to n. Okay, let us discuss example. The question is, if Cn3, so that means Nc3 plus Cn plus 2 3, so that means n plus 2 C3 equals to Pn3, so that means Np3, then find n. So this type of examples can be asked. So here just we are writing in a simpler form, that is Nc3 plus n plus 2 C3 equals to Np3. Now what we'll do, we'll just apply the formulas. Okay, now what is Nc3? So that is n factorial upon n minus 3 factorial into 3 factorial plus, now what is n plus 2 C3? So that is n plus 2 factorial divided by n plus 2 minus 3 Okay, so that means n minus 1 factorial into 3 factorial and equals to np3. So that means n factorial upon n minus 3 factorial. So then next, now see, what is n factorial? N factorial can be written as this n minus 1, n minus 2 into n minus 3 factorial. Okay, so that means n minus 1, n minus 2 into that n minus 3 factorial, it will be cancelled by this, okay, n minus 3 factorial. Now what is 3 factorial? That is 6. Now in same manner, what is n plus 2 factorial? So n plus 2 factorial, that is n plus 2, n plus 1, then n into n minus 1 factorial. So that will be cancelled. So the remaining will be n plus 2, n plus 1 and n. Divide by 6. And in same manner, in right hand side, n factorial can be written as this n minus 1, n minus 2 into n minus 3 factorial. And that is n minus 1, n minus 2. So if we expand this, we will get n plus 2, n plus 1 equals to 5 times n minus 1, n minus 2. And after expansion, we'll get 2n square minus 9n plus 4 equals to 0. Now we know that how to solve this quadratic equation. So the factors will be 2n minus 1, n minus 4 equals to 0. So hence we will get n equals to 1 by 2 or 4. So that means 4 is the answer. Why? Because n cannot be half. Okay, because we are selecting and arranging out of whatever the entries, but n cannot be half. It has to be an integer. Okay, so n cannot be half, so n equals to 4. Thank you.